This is a fun extra demo where I try to show the relevance of math as it applies to Maya and 3D animation using the concept of pi in conjunction with the circles and spheres discussion that we have. And as you may or may not know, pi is a concept where basically it is a concept of circles, or how basically is what it is a mathematical concept where well, I'm going to show you in just a second. It's a little hard to describe, so I'm going to show you visually. Pi is 3.14, and it goes on forever and ever and ever and ever, and I think this is going to I don't know how many places, but it just keeps on going. And here's a little explanation here. But I'm going to show you using a couple of concepts in Maya. I have a circle here, and I have it encased in a square. And basically what pi means is that you cannot make a circle from a square. At least that's how I understand it. So if I were to take this square here and I were to adjust it here and there, or I were to duplicate it, make another square. Oh, excuse me, didn't do that right. Duplicate it, and I make another square. And what I'm going to basically try to do is I'm going to try to create a circle using a square. Now I can go on forever and ever and ever and ever try to create a circle using these straight lines of the squares, and I could be doing this for infinity. And basically what would happen is that even if I were to just keep doing this for millions and millions of times, there's always going to be a space. It's never going to be a perfect circle. So that's one way of explaining pi, where the circle is a very unique shape, and it represents infinity. Now I'm going to show you another relevant example of how I like to explain pi. And what I've done here, and I'm not going to show you how to do this, this is for another lecture, but I'm going to make a tire in Maya. And just briefly how I've done this is I have an image template that I made that's repeatable. I made this in Photoshop, and it's a tire tread, and I've basically modeled my tire tread according to this template here, and then I've duplicated it I don't know, about 20 or so times, and made this long sort of beam here that's going to be curved into my tire. So I have this repeatable pattern here, and it's going to just kind of connect here. So I select what is going to be my tire, my geometry shape, and I'm going to go into the animation module, and I'm going to go to Create Deformers, Nonlinear, Bend. And I'm going to create what's called a bend deformer. And it's represented by this line here, and it just comes in 0, 0, rotate. If I were to go into the inputs here and go to the curvature and middle mouse drag, you can see that I can deform my shape using this, but I haven't oriented the deformer correctly. So I'm going to have to orient my deformer to bend it the way that I want to. So I'm going to go in here into rotate, and I'm going to rotate it 90. So you can't see, but it's underneath. It's rotated at 90 degrees. And something you can't see that I've already tested out, I'm going to rotate it in Z negative 90. And so what that did is it basically it oriented it on the Z axis. So now if I go into my my bend input here into my curvature, and I'm going to get a little closer so you can see, and I'm going to bend it here. Kaboom! And I can make my tire. Now where pi becomes relevant here is that I have a numeric input here, and I'm going to put in the numeric input of pi, 3.14. Boom! And there you go. You have a perfect circle. Now I want to illustrate something here. this is where pi becomes relevant, or you can you sort of see how the concept works. If you were to come real close and look here, I didn't do the whole mathematical, I only did it to 2 places, 3.14. I only did it to 3 decimal places, and if you can see here, there's a small gap. Let's add, so you know, pi is actually 3.157, I don't know, it goes on forever and ever. So if I were to 3.141, it makes it a little closer. Now I could be doing that forever, 3.15, and it's still never going to meet. There's still just a little bit of a gap there. Maya only has so much capabilities. It is not, you know, it doesn't have that precision to go to, you know, 1,000 places. So I'm just going to go to 3.142, and that will close it up. In actuality, it's actually overlapping just a little bit. But the concept is that even if I were to do this to 1 million places, decimal places, the 2 points, the 2 halves, or the 2 sections of the tire will actually never meet in theory. So that is sort of a little kind of a fun little explanation of a very abstract mathematical concept put in relevance to Maya. And it also shows you a way that you can use some of the numeric inputs and using some geometry and some math to do some of your modeling and even some of your animation functions and tasks.